chapter 5.
This call is now being recorded.
Okay, so everyone's ready. We continue our topic for intermolecular forces.
Yes, madam.
You ready? Okay. So for our last lesson, we have talked about chapter 4.4, which is your intermolecular forces. You still remember what is the difference between intra and inter? Anyone want to tell me what's the differences between intramolecular forces and intermolecular forces? Ada sesiapa nak share? Anyone want to tell me that what it means by intramolecular forces? What it means by intermolecular forces?
Inter is like between the molecule, between two molecules.
Okay. Between two separate molecules. Yes, how about intra? How about intramolecular forces? They're INTRA, intra.
Intra is forces in a molecule.
In a molecule, inside a molecule, within a molecule. Okay, so must make sure you know how to differentiate between intra and inter. Okay, if you want me to give you example, sure, no problem. If you look at the simple molecule like CH4, intra, inside a molecule, we say the bonding between C and H. This one is covalent bond. This is what you learn when you're drawing Lewis structure, when you learn about the bond formation. So that is intramolecular forces inside the molecule. But when we talk about intermolecule, that means it's between molecule, between atoms, between ion. So that means CH4 with CH4, what is the forces in between them? So this is what we call as the intermolecular forces. Okay, so chapter 4.4 intermolecular forces is divided into two types. We have our van der Waal, using short forms, yeah, van der Waal, and also hydrogen bonding. Hydrogen bonding is what we are going to look today. Okay, but we also look at the van der Waal forces last lesson, which is divided into the dipole-dipole and also the London forces. London forces also called as dispersion force, so you can use either one. So whether using short form over here, DD stand for dipole-dipole, LF stand for London forces. Okay, and in general, we say that dipole-dipole forces is stronger than London forces. Okay, that is previous lesson. But in today's lessons, we want to talk about hydrogen bonding. And then after that, we want to see overall how are we going to compare between the three type of forces over here. Okay, so here we go, hydrogen bonds. So sometimes the hydrogen bond can also call as hydrogen bonding. That means the same thing, bond or bonding. Oh, it refers to the forces of attractions between some of the selected polar molecule. Okay, polar molecule, some of them only. So over here is selected only, which have your hydrogen atoms that is directly bonded to F, O, or N atoms only. In other words, we say whenever you see the hydrogens directly attached to F or directly attached to O or directly attached to N, I don't care what is the remaining of your atoms lah. Okay, as long as you can see H is straight to FON, then you are going to have the hydrogen bond as the intermolecular forces. Okay, so for example, if let's say I give you the molecule like this, H2, is there any hydrogen bonds? Inside H2, is there any hydrogen bonds?
No.
No, because it doesn't have FON. Okay, or in other words, if I say I have a HCl, the last lesson you answer, right? As long as it doesn't attach to FON, then there is no hydrogen bond. Okay, then you need to figure out what is the other intermolecular forces in that molecule. Okay, so we are only focusing on three of this type only, yeah? H directly bonded to FON. Right, so given you the example at the bottom here, we have the H2O. So again, what we say is intermolecular forces. between two molecules of water. Okay, so we have the delta negative oxygen. If you still remember oxygen, we have two lone pair. On top of your oxygen, we have two lone pair. Okay, so this lone pair, one of the lone pair will make the hydrogen bond with the delta positive hydrogen of another molecule. So this is what we call as the hydrogen bond. Okay, so if Madam draw another structure, say H2O, we look it like this, two lone pair on top of H2O. Okay, so if I want to make a complete hydrogen bond, say we can make one hydrogen bonds over here with one of the lone pair. So it will attract it to one of the hydrogen of another molecule. And then this lone pair can also make a hydrogen with another hydrogen molecules. Okay, so you're focusing on the center here, yeah? But I highlight it for you to see. Okay, focusing on this H2O molecule. Okay, and then after that, the hydrogens on here, same molecule, will make the hydrogen bond also with another water molecule, but it's attracted to the oxygen. This hydrogen, again, will attracted to another water molecule. So you see, over the one molecule of water, you can actually form four hydrogen bonds with others water molecule. Okay, each water molecule can form four hydrogen bonds. Another example is given over here. We have NH3. Your ammonia gas or ammonia solution. So the hydrogen bonds, again, you see, is between the two of NH3 molecule. So between the nitrogen, which having the lone pair, okay, create this hydrogen bond with the delta positive hydrogen of another molecule. Okay, but in this case, Madam want to make sure you understand the hydrogen bond inside NH3, they can only form up to two hydrogen bonds only. In another words, because nitrogen has only one lone pair. Okay, so only one of the hydrogen bonds will make bonding with another molecule. So the lone pair inside the NH3, yeah, this molecular shape is strong, yeah? Okay, that will make the hydrogen bond with another molecule. Okay, so this one lone pair, and then we have another molecule of ammonia. Okay, so if you focusing on this structure, I can only make up to two hydrogen bonds. Okay, one from the lone pair or nitrogen, one from the hydrogen. Because the available one is only one lone pair. So dia kena matchy. Kalau awak tengok H2O, two lone pair, two hydrogen, so we can form four hydrogen bonds. But for NH3, because only one lone pair, so only one hydrogen bond, one hydrogen atom is going to form hydrogen bond. So only two hydrogen bonds here. Okay, so always remember lah, water can form more hydrogen bonds compared to others. Okay, water can form more hydrogen bond. Why do we say so? Because we have the factors that affecting your hydrogen bonds. So until here, do you have any questions related to the example for hydrogen bonds? Am I going too fast? Ada soalan ke? Okay, I show you one more example where we have the HF, yeah? Okay, so if you remember about the Lewis structures for HF, our hydrogen fluoride, there is three lone pair on our HF, but only one hydrogen atoms. So that means one of the hydrogen atoms, they are going to form the hydrogen bond with the fluorine of another molecule. Okay, either one of the lone pair will make the hydrogen bond with another molecules of hydrogen of HF. So that means in this term, HF can only make two hydrogen bonds. Regardless, you have three lone pair, but we only use one of the lone pair because there is only one hydrogen atom. So in order to look at the hydrogen bond, you have to see the ratio of hydrogen bond with the lone pair. NH3 satu lone pair saja, so kita akan pakai satu hydrogen bond. Okay, so ada 2 hydrogen bond. Okay, untuk HF, 1 hydrogen saja. So, salah satu lone pair akan dipakai untuk hydrogen bond. So, 2 hydrogen bond. Can you get it?
Madam,
Yes?
that is the convention way to draw the hydrogen bond.
Any convention way? No. Because they are free rotating, right? So they can be either direction. So as long as you can make hydrogen bond, that's okay.
Oh, okay, all right.
Right. All right. This is quite an abstract concept, yeah? But if you cannot see how these 3 molecules making hydrogen bond, no worries. You just remember more or less. You don't have to give the number. Okay, tak perlu bagi berapa banyak hydrogen yang boleh buat. Hanya perlu tahu banyak ataupun kurang ataupun tak ada. More hydrogen bond or less hydrogen bond or no hydrogen bond at all. Okay, so you only need to know about this one, yeah? So I'm going to write over here and you can jot down. Okay, either it's more hydrogen bond, less hydrogen bond, or no hydrogen bond at all. So don't worry about the numbers lah. So the more hydrogen bond, we always remember water because water can make more hydrogen bond. NH3, HF, they are having less hydrogen bond. Okay, can jot down over here if you can see my notes. H2O, less hydrogen bond, NH3, or maybe, HF. Okay, HF over here. Okay, so the example Madam showed on top, H2O and H3O and also HF, will link it to the factors. Okay. Similar like van der Waals forces, we have the factors that will affect your strength of the intermolecular forces. Of course, there are some factors that will affect the strength of your hydrogen bonds, and there are 2. So remember, the first one we go to electronegativity of FON. Who is the strongest between FO and N? Which one has the highest electronegativity?
F.
Fluorine. Okay, fluorine is more electronegative compared to oxygen, and then the least electronegative with between 3 of these atoms is nitrogen. Okay, so let's say we compare it between fluorine and nitrogen. Okay, the more electronegative the atoms, the stronger is your hydrogen bond. Okay, because the more electronegative atoms will attract the electron better. So more electronegative the atom is, whatever is atom you need to mention, and then the stronger will be its hydrogen bond. So this one will also link to the boiling point. Remember we talked about last week is the boiling point depends on the strength of intermolecular forces. Okay, boiling point depends on the strength of intermolecular forces. So if let's say you have a stronger bond, you will have a higher boiling point. So this one is electronegativity. The second factors is the number of hydrogen bonds. Again, when we say the factors number of hydrogen bond, you only mention more or less or no. No need to give number. Okay, you don't have to give how many are they. You just need to mention more hydrogen bond, less hydrogen bond, or no hydrogen bond at all. Okay, so for example here, sorry, madam terskip satu example ke atas. So electronegativity, if you compare HF, I go back a little bit. So HF and NH3. So comparing between HF and NH3, because both HF and NH3, they're having hydrogen bond. So we were comparing the electronegativity between fluorine and nitrogen. Okay, HF and H3 both having hydrogen bonds. Yeah, so comparing the electronegativity. Fluorine is more electronegative, therefore it has a stronger hydrogen bond. So you can make your own sentences as long you hit the point. Okay, more electronegative for fluorine, stronger hydrogen bond for HF. Okay. Is that good for electronegativity?
Yes.
Malay, yeah. Okay. So we go to the number of hydrogen bonds. So comparing between fluorine and oxygen. Okay. We do know that fluorine is more electronegative than oxygen. That is correct. Fluorine is more electronegative. But the H2O can make more hydrogen bond. So for the case where we comparing H2O and also HF, okay, H2O and also HF, we cannot look at the electronegativity, okay, because now water can make more hydrogen bond. Therefore, it will have a stronger hydrogen bond comparing to HF, even though the fluorine is more electronegative. Okay, so you must remember the example for H2O. The factors go for the number of hydrogen bonds. So a very special one because water, you use it daily. Water is a very, it has a very anomalous case. So whenever you see water, you remember about more hydrogen bonds. Okay. So two of these factors were affecting your strength of hydrogen bond, and it will also affecting your boiling point. So since H2O has a stronger hydrogen bond, therefore it will have the highest boiling point compared to HF. So in overall here, we will see the strength of hydrogen bond. We only talk about H2O, HF, and NH3 as example, yeah? Water will have the we have the strongest hydrogen bond. Okay, so this one is stronger amongst the three. Okay, followed by HF, followed by NH3. So NH3 having the weakest hydrogen bond. So if we want to comparing the boiling point, strongest hydrogen bond give you the highest boiling point. Also, water wins. Water having highest boiling point, followed by HF, followed by NH3. Okay, so when comparing both of this, we're comparing the number of hydrogen bond. When comparing HF and NH3, we're comparing about the electronegativity. Okay. Is that good for the comparison? H2O, HF, and also NH3. Ada soalan untuk comparison H2O, HF, and H3?
No, madam. I think everything's alright.
Okay, good. But beside H2O, beside hydrogen fluoride, beside ammonia, there is still other species which can have the hydrogen bond. Okay, as long as the hydrogen is directly attached to FON, they can have the hydrogen bond. Okay, so we see example alcohol. So alcohol CH3OH, if I open a little bit for the structure, you will see the hydrogen directly attached to oxygen. Or you will have amines, CH3, and directly attached to hydrogen. Okay, so alcohol and also amine, that is their name of classes, they could have the hydrogen bonds. Okay, so let's try a little bit of exercises and we will see how are we going to link this one to explanation. Okay, so why you want to know about the intermolecular forces? Because we want to compare their physical properties. Okay, remember when we talk about physical property is something that you can measure. It's something that you can see it. For example, boiling point, you can check it from the temperature. Okay, the solubility, you can see it from the how it can dissolve inside water. Okay, and also density of ice, you can see it whether an ice is floating or the liquid is sinking. So physical property is something you can see. All right. So what is boiling point? First of all, it depends on our strength of intermolecular forces. Okay, so when you want to talk about boiling point, you have to know, okay, what is the type of intermolecular forces? Okay, I'm using short form IMF over here to indicate intermolecular forces, yeah? So is it van der Waals? Is it dipole-dipole? Is it London forces or hydrogen bond? So you have to figure out, okay, the type of forces first before we compare them. Okay. Second, stronger the intermolecular forces, higher the boiling point. So in van der Waals forces, we talk about dipole-dipole is stronger than London forces. Okay. So now you talk about hydrogen bond. Hydrogen bond is much more stronger than both of them. Okay. Or in more general, if we're just comparing van der Waals, hydrogen bond with van der Waals forces, because DD and also LF underneath van der Waals. Okay. So in short, yeah, this one you have to remember. This one is in general. Hydrogen bond stronger than van der Waals forces. Hydrogen bond stronger than dipole-dipole and stronger than London forces. Okay. So first questions over here, Madam give you guideline how to begin with the questions. So arrange the following species in ascending order. What it means by ascending? What it means by ascending?
Menaik.
Meningkat kan, menaik, increasing order. So we will start with the lowest boiling point towards the highest boiling point. Okay, so you need to check what is your intermolecular forces for 4 of these species. Okay, so step 1, and in the question we got HCl, we got F2, your fluorine, we got an alcohol, methanol, and we have an amine, CH3 and H2. Okay, so let's look at your step 1. Identify the dominant type of IMF. Okay, what it means by dominant? It means which inside one molecule, which forces is stronger. That is the dominant force. Okay, for example, if we look at HCl, is HCl polar or non-polar?
Polar.
Polar, right? HCl is a polar molecule. So polar molecule, it will have what type of forces?
Dipole.
Dipole, and also the very basic one is London forces. Remember, London forces for every species. Okay, but we only want to compare the dominant. Siapa yang lagi kuat, kita comparekan dia dengan species lain. So in this case, we will choose the dipole to do comparison. Is that clear? Kita ambil yang forces yang lagi kuat untuk buat comparison lah. Okay, walaupun dia ada London forces, tapi kita tak compare dia. Okay, how about F2? Is it polar or non-polar?
Non.
Polar, non-polar, F2?
Non-polar.
Non-polar sebab dua atom adalah species yang atom yang sama, right? Okay, so forces apa yang ada?
London forces.
Alright, only London forces. Okay, number 3, CH3OH. Is it polar or non-polar?
Ini polar.
Polar or non-polar?
Polar.
Polar juga kan sebab dia punya structures, madam letak dia macam satu structure lebih kurang sama macam water. Tapi salah satu hydrogen kita gantikan dengan CH3. Okay, so the differences, okay, the polar arrow, okay, towards your more electronegative oxygen, towards the more electronegative oxygen. Right, therefore resultant dipole moment is not equals to 0 and therefore CH3OH is a polar molecule. Okay, but then for CH3OH, what is the dominant force?
Dipole.
Hydrogen bond.
Hydrogen.
So kalau kita punya molekul, kita nampak hydrogen direct kepada oksigen kan? So dia ada hydrogen bond. Dia polar. Dia pun ada dipole. Dia pun ada basic forces, London forces. Tapi kita nak compare, kita ambil yang paling kuat sekali. Is that clear?
Yes.
Okay, so we write down over here is the hydrogen bond. How about CH3NH2? Polar, non-polar?
Polar.
Polar as well. What is the dominant forces we have?
Hydrogen bond.
Again, the same thing, hydrogen bond, because you have your hydrogen directly attached to nitrogen. Okay, structure dia pun lebih kurang sama macam CH3OH. Dia nampak macam ni. Okay, so you nampak lah. So is that good for step 1? Can follow?
Yes.
Okay, so step 2, check if your intermolecular size is comparable. When we talk about molecular size, it means the molecular mass. Benda yang kita boleh kira. So if you check HCl 36.5, Madam dah kira untuk awak ya. Untuk sebagai rujukan sajalah. F2 38, CH3OH 32, CH3NH2 31. So the size is about the same. Dia tak ada beza banyak sangat. Bila Madam cakap beza, dia kena lebih daripada 40%. So if let's say you got 36.5 and the next element or next molecule you have about 78 or 80, that is different. But if the range is around there, we will consider they are similar. Okay, similar size, similar mass. So the factor is not about the molecular size. Okay, but we can compare about the forces. Sebab nampak kan dia punya perbezaan intermolecular forces. Did you see it? Do you see the intermolecular forces is different? Dipole-dipole, London forces, and hydrogen bond. So kita boleh kumpulkan for your HCl and F2, dipole-dipole London forces is under category of van der Waals. Whereas for your alcohol, CH3OH and also CH3NH2 is under the group for hydrogen bond. So which group give you lower boiling point? Is it van der Waals lower boiling point or hydrogen bond lower boiling point? Which forces is weaker, van der Waals or hydrogen bond?
Van der Waals.
Van der Waals is weaker.
Van der Waals is weaker. Hydrogen bond is stronger. So we look at van der Waals first. Okay, we look at van der Waals, yeah? Which forces is weaker between your HCl, the dipole-dipole, or the F2, the London forces? Which one is much weaker?
London forces is weaker.
London forces. So London forces will have the lowest boiling point because the forces is the weakest. Do you get it? Okay, so kita arrange. Step 3, kita kena arrange ikut susunan. So for this questions, ascending order, we will start with F2, followed by HCl, because HCl has dipole-dipole slightly stronger than our London forces. Okay, lepas tu kumpulan untuk HB pula, our punya hydrogen bond. So between CH3OH and also CH3NH2, both having hydrogen bond. So which one having a stronger hydrogen bond? Is it the OH or the NH2? Which hydrogen bond? Which hydrogen bond is stronger?
NH2.
The one with NH2, CH3NH2.
That one having stronger hydrogen bond.
Yes, because the size of it is the smallest.
Well, it doesn't relate to the size because the size is comparable. That means more or less the same. Comparable maksudnya dia lebih kurang sama. So, ingat sebelum ni Madam cakap kalau kita nak compare, kita kena compare benda yang berbeza. Benda yang sama kita tak boleh buat perbandingan. Sebab tak nampak. So, antara CH3OH and also CH3NH2, apa yang berbeza sebenarnya?
Hydrogen bond.
Number of hydrogen bond.
Dua-dua ada hydrogen bond. Apa yang berbeza? Cuba tengok formula dia.
Electronegativity.
Antara
O dengan N.
Antara O dengan N.
O dengan N. Siapa yang lagi elektronegatif? O ataupun N?
O.
O.
O. So, which one giving you a stronger hydrogen bond?
CH3OH.
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 Exactly. Okay, so CH3OH gives you a stronger hydrogen bond due to the electronegativity on oxygen. Okay, then we follow by CH3NH2. Lepas susun sebab awak kena dapat konsep dulu, baru kita kena buat ayat. Dapat konsep, susunkan awak punya order, baru kita explain, which is your step 4 and step 5. So for step 3, is there any questions? Boleh faham F2 followed by HCl followed by NH2 followed by OH.
Madam,
Yes.
kalau CH3OH tu, itu ada 2 lone pair kan?
Ya.
So kita boleh compare pakai hydrogen bond, number of hydrogen bond jugalah kan?
Sebab dia hydrogen dekat sini number of hydrogen bond sebenarnya dia sama. Kenapa kita cakapkan macam tu kalau awak fokus kat CH3OH, satu hydrogen saja. So kita akan pakai satu lone pair. Maksudnya 2 hydrogen bond saja yang dia boleh buat. Lepas tu untuk CH3NH2, dia hanya ada satu lone pair saja. So maksudnya dia akan dia akan guna salah satu hydrogen saja. So bilangan hydrogen bond untuk dua-dua spesies ini adalah sama. So you cannot compare.
Faham? Thank you, Madam.
Okay, right. So we're comparing the electronegativity instead. Right. So step 4, let's just construct the sentence over here, and Madam give you the blanks to fill in. So you have the idea. What should we do? So step 4, you need to group them by the same intermolecular forces. So in this case, we classify them into van der Waals and also hydrogen bond. Okay, we group them like just now Madam wrote on the top. F2 and HCl has, what forces do we have? F2HCl have what forces between its molecule? Their molecule actually. So what forces should I fill in the blank?
Van der forces.
Van der Waals.
Van der Waals, because both of them underneath the same group. Van der Waals. Okay, Van der Waals. Spelling check, yeah? While CH3 and H2, CH3OH has, both of them having
Hydrogen bond.
Hydrogen bond.
bonds between them. Okay, so which one is stronger, van der Waals or hydrogen bond?
Hydrogen bond.
Yes, you need to compare the strength. Remember, comparing the strength give you comparison for hydrogen for boiling point. So hydrogen bond is stronger than van der Waals forces. Ayat ini sangat penting sudah buat awak highlight kan. Comparison force mesti kena ada dalam awak punya explanation. Okay, thus the boiling point of CH2 and H2 and CH3OH are
Higher.
Stronger forces give you higher boiling point. So step 4 is following the group. Then after that, step 5, only we interpret one by one. So in each group, identify the factors that affecting the strength of each intermolecular forces. So we look at the first one first. For van der Waals, yeah? HCl is what molecule? Polar, non-polar?
Polar.
Okay, HCl is a polar molecule and has a stronger what force?
Dipole.
Dipole forces. Okay, kalau awak nampak perkataan stronger, saya sebenarnya sudah comparekan strength of your intermolecular forces. Kalau awak tak nak, awak boleh tulis macam ni. HCl is a polar molecule and has dipole forces. Full stop. Okay, and then after that, F2 is a non-polar molecule and has a kita ada London Forces dekat sini. So, kalau awak tak nak tulis stronger weaker dalam ayat sama, awak kena masukkan satu ayat yang baru. Dipole forces is stronger than London Forces. So, you have two options. Either you straight away put it here, or you make another new sentence to compare both of these forces. Okay, so HCl polar, stronger dipole. F2 is non-polar, weaker London Forces. So the words stronger, weaker, you show it comparison. So HCl has a lower or higher boiling point?
Higher.
Higher. Okay, how about the bottom one when we're comparing the alcohol and the amine? So oxygen is
More.
more electronegative than nitrogen. So hydrogen bond in CH3OH is stronger. So fill in the blanks. More energy is needed to overcome the hydrogen bonding between CH3. So this one is further explanation. Normally they don't have marks one to explain for you why the boiling point is higher, because the bonding is stronger. You need more energy to break it. Therefore, you have a higher boiling point. So this is a further explanation for you to understand it. Okay, so last point. Boiling point of CH2OH is higher than your amine. Okay. Boleh ke?
Boleh.
Sebenarnya awak nampak step 1 sampai step 5 macam sangat panjang kan? Sebenarnya cuma interpret, lepas tu awak kena explain dalam bentuk ayat. So this is a guideline for you. And let's just look at the next physical properties. Okay, our next physical properties is about solubility. Slightly easier. Because solubility, we only looking at the ability to form the forces with your solvent. So look at the first sentence over here. Solubility, ability to form hydrogen bond with water molecule. So if let's say your solvent is water, then you have to mention able to make hydrogen bond with water molecule. Therefore, it is soluble in water. Bila dia dapat buat bonding, dia adalah what do you call that? It is soluble. Larutlah, dia akan larut dalam air. Okay. But if let's say your solvent is not water, your solvent is something else. For example, if you have benzene solvent, which is a non-polar solvent. So non-polar akan bagi hint. Non-polar hanya boleh ada London Forces sahaja. Okay, non-polar hanya ada London Forces sahaja. Okay, so the ability to form the van der Waals forces, van der Waals represent your London Forces lah. Okay, with the non-polar solvent. If in this case you want to say ability to form the London Forces also accepted with the non-polar solvent. Benzene, formula dia C6H6. So nampak C dengan H dalam formula tu, dia memang non-polar. Tak payah fikir dia punya bentuk macam mana. CH memang non-polar. Okay. Satu contoh lagi solvent yang non-polar, Madam bagi dekat sini, boleh catat CCl4. Also a non-polar solvent. Okay. But the main thing you have to check lah, what is your solvent? Kalau solvent water, memang kita fokus dekat hydrogen bonding. Is that clear? Is that clear? Hello, anybody home?
Clear.
Anybody home?
Understood, madam.
Yes, madam.
Nangis tak ada respon. Okay, tak apa, kita continue soalannya. Right, questions with guideline. Compare your solubility of the following compound in water. Kalau nampak water, bonding apa yang kita nak?
Hydrogen bond.
Ya, kita nak tengok sama ada dia boleh form hydrogen bond ataupun tidak. Okay, so step 1, identify the dominant type of intermolecular forces. So CH3OH, what is the dominant type?
Hydrogen.
Hydrogen bond. How about CH3? CH3 hanya nampak C dengan H, dia adalah non-polar. Ya, so London Forces sahaja. So madam guna short form HBLF. Okay, step 2, arrange. Depend on the question. Yang ini compare, so tak ada arrange. Kita tak ada step 2. Okay. Kalau arrange order, maksudnya dia increasing or decreasing order. If you have more than 2 elements, then only we will use the trend. Baru akan ada simbol ini. Ataupun ini. Ataupun awak punya arrow. Okey. Tapi untuk soalan ini, siapa yang akan larut dalam water? If you look at CH3OH, the first steps right here. Which one will dissolve in water?
London forces got CH3, CH2, CH3.
CH3 will dissolve in water.
CH3OH.
CH2OH.
Okay, fokus kat solvent dia. Solvent dia sekarang water. Jadi kita fokus kat hydrogen bond. Siapa yang boleh buat hydrogen bond, dia akan larut dalam air. So in this case, you have already identified the forces just now, isn't it? So we know that the alcohol is soluble because it can form hydrogen bond. How about CH3, CH3? Is it soluble or insoluble? Or less soluble?
Insoluble.
Insoluble.
Soluble. Sebab dia langsung tak ada hydrogen bond. Jadi dia langsung tak boleh larut. Okay, so kita tengok dia punya explanation ya. Okay, step 3, explain the ability of each species to form hydrogen bonds with water molecule. Dia form bond dengan siapa? Kena ada ya. So CH3OH is soluble in water because it is a polar molecule and it can form kita punya hydrogen bonds with water molecule. So highlight kan with water molecule. Jangan sampai hydrogen bond lepas tu awak stop. So with water molecule is important. And then for CH3, it is insoluble in water because it is a non-polar molecule. Okay, it's only have the weak London forces and unable to form hydrogen bond with water molecule. So untuk London forces nak tulis pun boleh. Only has weak London forces. Tapi kita punya main focus boleh ataupun tidak dia form bond dengan water. Okay?
Yeah.
Is it good to follow?
Yes.
Yes.
Everything's good, madam.
Okay, so our third physical property is the density of water. So compare the density of ice compare with water. So normally in a glass of ice syrup ke whatever ke, awak punya ice biasa dia dekat mana? Ke atas. Siapa punya ice tenggelam kat bawah nanti bagi tahu madam ya. Okay, so this is your ice floating on top of water. So now you're learning about the reason why. So we know that water is denser than ice, or the ice is less than water. This is because in the solid state of H2O, ice, it means solid state H2O. Each H2O molecule is arranged tetrahedrally. So if you still remember, in your oxygen, we have a tetrahedral arrangement. Okay. Tetrahedral hydrogen bonded to 4 other H2O molecule in a repeated 3D network. So showing over here. So this is the tetrahedral hydrogen bond. So if you focus on the first H2O madam showing, this will connect to another hexagon. So this one will connect to another hexagon. So until one point, when they are all making one bond, you will see the hexagon occur inside your ice crystal. So this one's something like this lah. Okay, you will have the hexagon shape all over in the ice. Okay, when one of the oxygen is making 4 bond tetrahedrally. So this one is making another bond with another water molecule. Okay, so over here also making another bond, and something else. So each of the water molecule, just now madam said, can form 4 hydrogen bond. Okay, can form 4 hydrogen bond. Therefore, inside your ice structure, because ice they freeze already. Okay, they have a specific shape. So it will provide an open shape, okay, an open shape with a hexagon shape over here. So we say open hexagonally shaped ice. Kalau compare dengan water, Madam tunjuk kalau dekat surrounding water. Water, the shape is not rigid. So let's say I have the water molecule over here. Okay, I can form the hydrogen bond randomly. Because in liquid is not arranged rigidly. Di air memang boleh bergerak kan, dia boleh flow here and there, boleh ikut shape container. Okay, so when you look at the arrangement for water in liquid form, okay, it's not open space. It's not hexagonally fixed shape. Therefore, we will see the differences between their structure. So when in ice, the H2O is tetrahedrally bonded. You will have this open hexagon shape, which means we will have a bigger volume. Volume yang dekat punya hexagon shape dekat sini kosong. This is an empty space. You have a bigger volume. Compared to the volume in liquid, only a very small one. So, if you remember about the density formula, density equals to mass over volume. The bigger volume in the ice, okay, give you a lower density. Okay, again, in ice, the solid state of water, you have a bigger volume. Okay, reason? Because you have open hexagon shape of the ice. Therefore, you are having a lower density for the ice and result in the ice floating on top of water. Okay, so boleh gunalah konsep untuk punya density formula. Bigger volume, lower density. But in term, if you want to explain about liquid, liquid has a smaller volume, therefore higher density. Therefore, liquid water will sink below the ice. Is that okay?
Yes, madam.
So, yang Madam highlightkan dalam warna merah tu, boleh fahamkan lepas tu dekat sini. Bigger volume, lower density, ice float. Okay. Any question for density of water, density of ice?
Oh,
Okay, kejap ya. Untuk so in this case, for this hour, the one that Mother want you to submit into Google Classroom, ada banyak lagi yang belum hantar untuk exercise hari itulah, tapi Mother bagi deadline sampai hari ni kalau ada orang yang perasan sampai 30. Sebab soalan banyak. Ramai juga yang belum hantar. Okay. So, Madam bagi 4 soalan je lah ya. The explanation ice float water just now, the answer is given already. It's exactly the same as the previous page. Okay, so into GC, I want question 1 to 3 and also solubility question 7. Question 1, question 2, question 3, and question 7 into GC. Okay, so Madam will explain for 4, 5, and also 8, but seems that the time is not enough, so maybe we try one of this. Okay, question 4. You having 3 compound. Normally, the compound they will give you the formula because you are yet to learn about the structure: propane, fluoroethane, ethanol. So normally you will given the formula. Okay, so arrange this compound in order of increasing boiling point. So Madam dah bagi formula yang awak salin dulu. Propane, fluoroethane, ethanol. Okay, so we want to arrange 3 of these species in increasing boiling point. So we want to see what is their dominant force. So explain your answer based on the type of intermolecular forces. Okay, so can I know in propane, okay, is it polar or non-polar? So we interpret down below ya. Propane, polar,
Non-polar.
non-polar. Forces apa yang ada dalam propane?
London forces.
Very good. How about fluoroethane?
Polar.
Polar. Forces apa yang
Hydrogen
ada?
bond.
Hydrogen bond.
Dominant forces.
Hydrogen bond.
Okay.
Hydrogen bond. Because
What?
because here
Because
got hydrogen and fluorine.
Got hydrogen and fluorine. Is the hydrogen directly attached to fluorine? That is the main question ya. Is hydrogen directly attached to fluorine? So kita boleh teka sebenarnya kalau sudah bagi formula kan. Okay. Center memang carbon. Center memang carbon sebab satu carbon maximum minimum memang kena octet. Kena ada 4 bond. Okay. Hydrogen mesti kena surrounding sebab dia hanya boleh 2 elektron saja. Duplet. So let's just fill in your hydrogen. You got only 5 hydrogen, isn't it? CH3. Okay, CH3 ada 3 hydrogen. CH2 satu atas, satu bawah. So fluorine dia kat mana? Fluorine nak masukkan mana?
Attached dekat
Di situ
C.
je. So ada tak hydrogen dia direct kepada fluorine?
No.
Tak ada.
No. So tak ada hydrogen bond. So if let's say no hydrogen bond, then what is the dominant force for fluoroethane?
Dipole.
Dipole sahaja. Betul. So kena check hati-hati ya. Bukan nampak hydrogen fluorine dia mesti ada hydrogen bond. Kena tengok sama ada dia attach direct ataupun tidak. Okay, last one. Ethanol, CH3, CH2, OH. Polar, non-polar?
Polar.
Polar. Dominant force?
Hydrogen bond.
Where is it hydrogen bond now?
DOH.
DOH. Hydrogen direct to oxygen. Well done. Okay, let's see the explanations. Yeah? Contain hydroxy group. Okay, which one contain hydroxy group?
Ethanol.
Ethanol. So either you're using the formula or you're using the words. So ethanol contain hydroxy group and can form?
Hydrogen bond.
Hydrogen bond, yes. Okay, it can form hydrogen bond between its molecule. So the one that Madam highlight in red color is very important sentence. We compare the force. Okay, so hydrogen bonding or hydrogen bond is stronger than van der Waals forces. Okay, because you got London, you got dipole. So we compare with van der Waals forces. Okay, think wrong spelling, yeah. More energy is needed to overcome the hydrogen bonding between ethanol molecules, and therefore ethanol has higher boiling point comparing to your propane and also fluoroethane. These two you fill in yourself. Okay, comparing with the other two. Right, the second paragraph over here, you can start either one. Either you want to start with fluoroethane or you want to start with propane. That is fine. So let's say we start with fluoroethane, yeah? Okay, so fluoroethane is a polar molecule. So kat atas sudah madam ajar macam mana nak interpret. So kita hanya buat ayat dia saja. Okay, so and it has dipole forces. Forces. Okay. How about propane? Now you fill in your odd. Propane is a non-polar molecule and it has London forces. Okay, between its molecule. Therefore, you compare the strength, dipole-dipole interaction of dipole-dipole forces are stronger than London forces. Okay, ini salah satu contoh macam mana nak buat ayat ataupun awak nak ikut macam tadi. Fluoroethane is a polar molecule and it has a stronger dipole-dipole forces. And propane is a non-polar molecule and it has weaker London forces. Kalau sudah ada perkataan stronger, weaker, ayat yang ketiga tidak perlu. So either one you choose. The important one to compare the strength. Okay, last sentence. Boiling point of which one is higher? Fluoroethane or propane? Which one is higher? Fluoroethane.
Fluoroethane.
Okay, fluoroethane is higher than propane. due to a stronger dipole-dipole forces between them. Okay, so any questions for this part?
Oh,
Tak ada. Well, okay. Meda tengok contoh apa lagi yang Meda nak bagi ya. Kejap. Okay, this one interesting. Question number 5. Yang tadi sudah siap salin
Sudah tangkap gambar.
Tu tak tambah. Lain? Boleh sebab Madam nak mempercepatkan proses. That's why Madam give you the empty space so you can straight away drop in. But normally the answer you need to write on your own, huh? Okay.
Madam,
Yeah.
this one actually, where is it? Because I can't find it.
Okay.
Is it actually in the notes or?
This empty space, no. It's Madam only give you the exercises only.
Oh, I thought I'm missing something.
No. Madam give you this guideline. It's kind of like guideline how to make sentences. Tapi sebab Madam nak cepat kan, kalau awak nak tunggu Madam tulis satu persatu lambat lah. Tapi awak boleh tangkap gambar kan?
Boleh.
And you can reassess back because this one I won't delete the page. You can reassess back this page in OneNote, the link that Madam sent in my link. Okay. One more example before our topical test. 4.5 will be on next week. Okay, last part for chapter 4 will be on next Sunday. Okay, so question number 5. Ethanol, molar mass 46 gram per mole. It boils at 78 degrees Celsius, whereas water, H2O, with a molar mass of 18 gram per mole boils at 100 degrees Celsius. Okay, so if you look at the information, Madam bring it into kind of like a table for you to compare. Kalau awak letak side by side, awak baru akan nampak dia punya comparison. Okay, so kita interpret dulu dia punya information sebelum jawab. Supposingly, if you're looking at the mass, 46 compare with 18, which one is higher? 46. Okay, yang ini bukan comparable sebab dia berbeza lebih daripada it's more than half already the differences, more than 50% already. Okay. Lepas tu kalau kita tengok mass sahaja kita tengok mass sahaja, supposedly the bigger the mass or bigger the size, it will give you higher boiling point, isn't it? Kalau kita tengok mass sahaja. So the factors will be the bigger the molecular mass, the greater the polarizability, the stronger the forces, and then higher boiling point. But this is not the case. This is not the case because water having higher boiling point. So now we go back to the structures of its own. C2H5OH and H2. So what Madam want to know? What is the forces for two of these species? What is the forces for C2H5OH?
Hydrogen bond.
Hydrogen bond.
Hydrogen bond. For H2O?
Hydrogen bond.
Okay. Both having hydrogen bond. Both having oxygen. So what we are going to compare? Oxygen sama, Madam. Lepas tu, hydrogen bond type dia pun sama. Tapi mass dia tak sama. Tapi kita tak boleh compare mass. So, jadi apa berlaku?
Compare berapa banyak hidrogen yang dapat attach dengan oksigen. Baru kita
Yeah.
tahu berapa banyak hidrogen bond yang boleh dihasilkan.
Correct, exactly. That's why Madam asked you to understand and remember that water, H2O, can make more hydrogen bond. Kalau awak nak tahu bilangan yang exact, H2O can form up to 4 hydrogen bond. Whereas if you look at C2H5OH, 2 lone pair with only 1 hydrogen. So for alcohol, the ethanol can only make 2 hydrogen bond. Tapi ingat, Madam tak nak bilangan. Madam nak awak compare more or less. Ingat kalau awak bagi bilangan, ini ada 4, ini ada 2, itu bukan comparison. Itu hanya statement sahaja. Compare maksudnya, dia lebih banyak. Dia kurang. Dia tak langsung tak ada. Okay, so in this case, we will say water can form more hydrogen bond, or the ethanol can form less hydrogen bond. So let's see the explanation here. Both ethanol and waters are, what should I fill in? Are molecule and can form nak isi apa?
Polar.
Polar. Molecule and can form hydrogen
Hydrogen
bond. Good. However, water molecule can form more hydrogen bond. When you're having more hydrogen bond, so in overall, we will say the water will have a stronger hydrogen bond. So kalau nak shortcutkan ayat lagi, boleh. However, water molecule can form more and stronger hydrogen bond. Shortcutkan 2 ayat dalam satu. Tapi dia ada words dia ada keywords. More and stronger. That show comparison. Okay, more and stronger hydrogen bond. So more energy is needed to overcome this strong hydrogen bonding in water, and thus the boiling point of water is higher than ethanol. Okay, ingat bila kita buat comparison, mesti kena cari benda yang berbeza untuk buat comparison. The same thing cannot compare. Alright, is that good for everyone?
Yes.
Clear, yeah?
Clear, madam.
Right. For question number 8, you all can try first lah. If you got any questions, then madam can discuss later on, because the explanation is quite short. You can screenshot this one. Okay, you can screenshot this one. And then structure for CH3, OCH3, madam show it over here. And then think about what force could we have for this methyl ether. Okay, and then you try to fill in the blank for question number 8. Dan screenshot.
Done.
Yang lain?
Dah, madam.
Okay, so for our topic on coming Sunday, we will talk about the metallic bond. Metallic bond is also quite short. Will be finished within an hour. Okay, so on Sunday, Sunday, Tuesday, Thursday. Okay, so on Sunday we will continue into chapter 5. Topical test, madam, see when madam want to give you. Or you straight away want topical test on Thursday or on Sunday. Topical test chapter 4. Which one you prefer? You want straight on Sunday?
Boleh je teacher mana-mana.
Apa dia? Kejap ya, madam stop sharing first. And I want to give you the attendance. Hold on ya.
Madam, I think you can switch off the recordings right now.
Yeah, hold on. Madam turn off. Banyak sangat benda nak buat. Kejap ya.